So today we're going to be talking about how to do calculations with moles. So I'm going to talk about some various aspects of how we do calculations with moles today. If at any point you're feeling like you need to get advanced past this introductory stuff, if you go later in the video, I'll be doing some of the more advanced calculations. But to start off with, I'm just going to do a little introductory of what the mole is and how we do some simple one-step, then two-step, and then finally three-step conversions. So before we go further with calculations of the mole, let's just do a recap what the mole is. So a mole is equal to 6.02 times 10 to the 23rd atoms or molecule. That's how much one mole is. We call that Avogadro's number, and it was named after its discoverer. Now, if we know we have 1 mole of a substance, that is also equal to the molecular mass of an atom or a molecule. How we can determine the mass of a mole of any substance is by looking at the periodic table. For example, if you go on your periodic table, you'll see that sodium has a molar mass of 22.99 AMUs. We can also express that as grams per mole. So there are 22.99 grams per mole of sodium. If we've got a mole of chlorine, that has a mass of 35.45 grams per mole, or AMUs. So if we know the substance, we can just go to the periodic table and determine about how many grams it takes to get a mole of that substance. If we need to determine the molar mass of a compound, all we have to do is just add up the atomic weights of its constituent elements, and that'll tell us the number of grams per mole in a compound. So now that we have a mole identified and given it some conversion factors, now we can start trying some calculations with the mole. So for our first example, we're going to convert 3.68 grams of sodium chloride to moles of sodium chloride. Now, while you're doing this video, and you can kind of stop it along the way and calculate as we go. But I'm going to kind of go through real quick, so just if you need time to write things down, just go ahead and pause it and do your calculations as I do my calculations. So when we start any mole problem, write down what you know. So in this case, I have 3.68 grams of NaCl. Your next step is to set up a fraction using unit analysis. If I want to convert from grams to moles, in order to cancel, I'll have to put grams on the bottom, so I'll put grams of NaCl on the bottom, and moles of NaCl on the top. The next thing I'm going to do is I'm going to go to my periodic table and add up the mass of sodium chloride. And we already did this earlier in the video, and that's a mass of 58.44 grams in 1 mole. That's what that unit means, a gram per mole. That's how many grams are in 1 mole. Now we can go ahead and calculate it. Remember, we can do our cancellation as we go. And now we're just left with moles. Okay, time to check your work. You should have gotten 0.063 moles of sodium chloride. For our next problem, we'll be converting moles to grams. We'll be converting 0.450 moles of silver to grams of silver. So again, start by writing what we know. 0.450 moles of silver, Ag. Set up our unit analysis with our fraction. And on the bottom here, since we're canceling out moles, put moles of Ag down here, and grams of Ag on top. Now let's just do a real quick recap where we get our grams of Ag. Where we get our grams of Ag, again, is that atomic mass off the periodic table. Again, this is going to tell us how many grams are in a mole of any atom. All right, back to our calculations, we'll write that down. In 1 mole, we have 107.87 grams. All right, go ahead and calculate and see what you get. Okay, hopefully you got 48.5 grams of silver. Now we're going to do one more one-step mole problem before we move on to some more complex problems. All right, in our last problem, we're going to convert atoms to moles. So in this problem, we're going to convert 1.50 times 10 to the 23rd atoms of sulfur into moles of sulfur. So again, start out by, like we always do, write down what we know. 1.50 times 10 to the 23rd atoms of sulfur. Set up our unit analysis, and this time on the bottom, for atoms, our conversion from atoms to moles is using Avogadro's number. 6.02 times 10 to the 23rd atoms of sulfur are in 1 mole of sulfur. Again, we can cancel units, and now we can throw this into our calculator. All right, now go ahead and run that through your calculator. Now, if you don't recall how to put scientific notation in your calculator, I'd recommend two things. One, if you Google the model of your calculator, you'll have a good rundown of how to do that. And if you still have troubles, come on into class and talk to me, and we can run through how your specific calculator handles scientific notation. Okay, so run that through your calculator. We'll see what you get. All right, so hopefully you've got 0.249 moles of S. So in the next segment of this video, what we're going to start doing is doing some more difficult problems with 2 to 3 steps. In order to do conversions with moles, I recommend using this graphic organizer I'm about to show you. So I'm going to draw it on my paper. So what you see here might look a little funny, but it's a way we can figure out how many steps we need to use when we do any of our mole problems. We can kind of put double arrows connecting each of these different spots on our graphic organizer. So say we need to go from grams to atoms, we can count our number of steps. To go from grams to atoms would take 1, 2 steps. Each place we see arrows indicates the number of steps that we need to take. If we're talking about the same substance, we stay on one line, but if we change substances, we are going to go on to the second line, and I'll show you how to do that in just a moment. For an abbreviated way to draw this is to simply just put G, M, A. I've had a lot of students say they remember this as grandma, G, M, and A. But whatever method works for you, go ahead and use that. Okay, so let's try a two-step problem. In 4.03 grams of lead, how many atoms are there? Let's take a look how we would use the graphic organizer. So here's what you do. We're starting with grams of lead. We want to get to atoms of lead. So that's going to take 1, 2 steps. We have to go from grams to moles and then convert the moles into atoms. Basically, the number of lines will dictate how many sets of parentheses we need to put down. Okay, let's begin. 4.30 grams of lead, and we've already established that we need to take 2 steps here. Put our grams of lead below, 1 mole of lead. Look it up on our periodic table. Cancel our grams, and now we're into moles. Now we go to our next step. To cancel moles, we put moles on the bottom. And the top, we'll put atoms of lead, because that's what we're trying to get to. How many atoms per mole? 6.02 times 10 to the 23rd. And now go ahead and do your calculation. So hopefully you got 1.17 times 10 to the 22nd atoms of lead. The next thing we'll do is a 3-step problem. So in this problem, we're given that we have 130.5 grams of zinc chloride, and we want to know how many grams of chloride are contained within it. Our first step is to put this little graphic organizer down. Grams, moles, atoms. Grams and moles and atoms. Now, at first, if you need to have this, keep on doing it, but eventually you might find yourself not needing to actually draw this graphic organizer at all. So let's fill in what we need to do. We've been given grams of zinc chloride. What we want to convert to is grams of chloride. So the second line represents a second substance. Now we can count how many steps it's going to take us. 1, 2, 3 steps. Grams to moles of zinc chloride, moles of zinc chloride to moles of chloride, and then moles of chloride to grams of chloride. So let's start throwing our numbers in. We've got 130.5 grams of zinc chloride, and then we've established that we're going to need to do 3 steps, so we can draw our 3 brackets right away. Let's do the first conversion. Grams of zinc chloride to moles of zinc chloride. Go to your periodic table, calculate the mass. You get 136.29 grams of zinc chloride in a mole of zinc chloride. So now we've gotten out of our grams, we're in moles. Now, this next part is a little different than before. So what we have to look at is we have to relate how many atoms of chlorine are contained in 1 molecule of zinc chloride. So we can say that in 1 mole, or even in 1 molecule of zinc chloride, we have 2 chlorine atoms, or 2 moles of chlorine. So basically when we do these type of problems, our number we put in front of moles here is going to just be the subscript we got from each individual atom. The molecule itself will always get a 1, and this will always be the subscript from the formula. All right, let's do our last conversion. So we've gotten rid of moles of zinc chloride, and now we're into moles of chlorine or chloride. So now put moles in the bottom, and 1 mole of chloride. Go to our periodic table, is 35.45 grams of chlorine or chloride. And now we've gotten out of moles of chlorine, and we're finally to our goal of grams of chlorine, and we can run that through our calculator. Now hopefully after calculating you got 67.89 grams of chlorine. Well, that's all I've got about doing our mole problems and some of the problem solving strategies. If you need additional assistance, be sure to drop by anytime before, after school, or during advisory.